This is Tensor Flow and Slippery Rock Creek, Predicting River Levels with Machine Learning by Xavier Reese. I chose this project with a problem in mind, and the problem is that I want an accurate prediction of Slippery Rock Creek levels for whitewater kayaking purposes. But the USGS, a government-run water data source that commonly has predictions for river levels, doesn't have predictions for Slippery Rock Creek because it's too small. And I want to learn machine learning and Python, both things I have not done before because I mostly program and am actually employed in JavaScript-based web development. The first step in this program was to choose the data that would be used to train and test my model. I chose the river levels of three rivers: the Slippery Rock Creek itself, Muddy Creek, the only tributary of Slippery Rock that has a gauge, and the Connoquenessing, which is nearby to Slippery Rock and has a very close watershed, so the data would be accurate and helpful. I also chose the weather data from three weather stations: Newcastle, Franklin, and Slippery Rock University. Even though the precipitation at Newcastle and Franklin locations would end up in different rivers, these were the locations with the best data coverage, although even then only around 95%, meaning 5% of the data values were missing. Searching through and spacing the data correctly, as well as the lack of complete data, made me appreciate the work that would go into data science, another field of computer science I've never truly delved into. After collecting my data from my sources and organizing it all into one spreadsheet that I could use to create these graphs, you can now see the holes missing from some of the data. While the river levels of the Slip, the Connoquenessing, and Muddy Creek all have complete coverage, some of it is estimated when the gauge is down to fill in the data holes, you can see that other places, such as Newcastle, for example, missing two large chunks of their temperature data. And Franklin is missing an entire year of all of their data. And finally, you can see the distribution charts of all of my data. You can see that river levels tend to be in one area. Sometimes they go low, sometimes they go high, but of course they also will go high into a flood stage. And you can see that precipitation levels kind of follow the same track and are what's mainly causing the changes in river levels. Temperature data changes as well. There's a high center and a low center, as well as some that are outside the norm. Before I go any further, I want to talk about the article that I was using as a primary guide for my project. I used Using Machine Learning to Predict Rhine Water Levels on towardsdatascience.com. By using this article, I was able to make sure that my code would be close to operational from the start, although it still required plenty of adaptation and debugging to get it working for my project. This way, I'm left with a working program that I can continue to adapt and improve upon in the future, instead of forcing myself to learn everything I possibly would need to know and still ending up with an inferior project. With the way I learn best in programming, this is also a method that will lead me to picking up skills and good habits quicker. Of course, I want to learn the basics for doing the trial and error myself, but this isn't something I have the time for as of now, and it's hard to learn without a full commitment. An overview of how this program works. First, the Python loads the data into a readable format from the Excel spreadsheet. Then the data is standardized by converting each value to the number of standard deviations from the mean of that column. For each column, we then create a copy of the previous week's data. Each day is a different column. This is to create data rows that can be used as input for predicting the water levels on Slippery Rock Creek based on the 7 preceding days of rain, temperatures, and river levels. Then 80% of this data is plugged into Tensor Flow's LSTM network model. This is a model that is best known for doing well in predicting hydrological levels such as this. The result of this model is then tested against the remaining 20% of data. Here you can see the overall results of this program. The orange is the predictions made by the model, and the blue is the actual river levels on those days. Overall, the model worked and is quite accurate. It does drop off on some of the peaks, especially as you'll see in some of the closer up shots. Here you can see a graph of the mean absolute error of the model. On the x-axis, you can see the progression of the model as each round of learning took place, with the rightmost being the final model. And the y-axis is measured in standard deviations. In this case, one standard deviation is around 800 CFS. CFS stands for cubic feet per second, and is the most common river flow measurement. Overall, this means that the error of the model against the test data was just about 200 CFS. If you can predict the river level of Slippery Rock Creek within 200 CFS, you can have a very good idea of what you're getting into when kayaking it. Here you can see two spans of data to help represent how the model is performing. On the left, you can see a span of time that has a lot of peaks, and you can see that the model tends to underpredict these peaks. This is probably due to some missing data of precipitation within the watershed that just isn't picked up correctly by the data I could find. And on the right, you can see a more typical span of time. And even at the low levels, especially at the low levels without spikes, the model tends to do a really good job of predicting the level. Overall, I was very happy with how my project went and the program I was left with. I found my introduction to machine learning and Python, and I have a deeper appreciation and understanding of data science after my search and my editing of my data. I also have been left with a legitimately useful tool for myself and my kayaking friends. In the future, I would like to obtain better data and adjust the code to predict future values instead of predicting relatively present values based on the last week. Then I could look at getting the results onto the TRPC webpage. TRPC is the Three Rivers Paddling Club, and there are thousands of kayakers belonging to their Facebook who all could visit this page and see levels of the slip, not to mention the many other kayakers who travel from different states and from around the state of Pennsylvania to kayak the slip.